In the quiet halls of a modern museum, a small, corroded bronze object sits under glass, its purpose a mystery for centuries. Known as the Antikythera Mechanism, this ancient device, over 2,000 years old, has baffled scientists with its intricate gears and precise astronomical calculations. How could a civilization without modern technology create something so advanced? This is just one of the many astonishing achievements of ancient astronomers' cultures that mapped the stars, predicted eclipses, and built monuments aligned with celestial events, all without telescopes or computers. What did they know that we're only beginning to uncover, and what secrets lie hidden in their star charts and stone circles? In this video, we'll journey through time to explore the greatest achievements of ancient astronomy discoveries that not only shaped their world but continue to influence ours. From the precision of Mayan calendars to the celestial alignments of the pyramids, prepare to see the cosmos through the eyes of those who first dared to study the heavens. Picture this, a corroded, fragmented artifact lying at the bottom of the Aegean Sea, hidden among the ruins of a shipwreck for over 2,000 years. When it was discovered in 1901 near the island of Antikythera, no one could have guessed that this unassuming lump of bronze and wood would rewrite our understanding of ancient technology. Known today as the Antikythera Mechanism, this remarkable device is often hailed as the world's first analog computer, a testament to the ingenuity of ancient Greece. The mechanism's purpose to predict celestial events with astonishing precision. Imagine holding a device that could forecast solar and lunar eclipses, track the cycles of the moon, and even calculate the positions of the planets. For its time, it was nothing short of revolutionary. The Antikythera Mechanism didn't just tell time, it mapped the heavens. But what makes this device truly extraordinary is its complexity. Inside its wooden casing lay a series of intricate bronze gears, some as small as a fingernail, meticulously designed to mimic the movements of celestial bodies. Researchers have spent decades piecing together how it worked, and even today, its sophistication leaves modern experts in awe. As one historian put it, the Antikythera Mechanism is a window into the mind of ancient engineers who dared to dream beyond the limits of their time. What's even more fascinating is how this device challenges our assumptions about ancient civilizations. We often think of the past as a time of simplicity, but the Antikythera Mechanism proves otherwise. It reveals a level of astronomical knowledge and mechanical skill that rivals some of the tools we use today. And yet, this wasn't the only ancient marvel that defied its era. As we explore further, you'll discover other tools and inventions that showcase how humanity's quest to understand the cosmos has always been driven by innovation and curiosity. The Antikythera Mechanism is just the beginning. The Babylonians were more than just builders of towering ziggurats and creators of the Code of Hammurabi. They were also some of history's earliest astronomers, meticulously mapping the night sky with a precision that would influence civilizations for centuries. Around 1200 BCE, long before telescopes or modern technology, they began compiling star catalogs on clay tablets, recording the movements of celestial bodies with astonishing accuracy. These ancient astronomers didn't just gaze at the stars for curiosity's sake. They used their observations to shape daily life, from predicting seasonal changes for agriculture to crafting astrological predictions that guided kings and kingdoms. One of their most remarkable achievements was the discovery of the Saros cycle, a period of approximately 18 years, 11 days, and 8 hours that predicts when solar and lunar eclipses will occur. This groundbreaking insight allowed them to forecast celestial events with remarkable consistency, a feat that still amazes modern scientists. Imagine the dedication it took to track the heavens over generations, carving their findings into clay tablets that have survived thousands of years. These tablets, some of which are now housed in museums, reveal not only their technical skill but also their deep reverence for the cosmos. But the Babylonians didn't keep their knowledge to themselves. Their star catalogs and astronomical methods heavily influenced Greek thinkers like Hipparchus and Ptolemy, who built upon this foundation to advance their own understanding of the universe. The Babylonians' work bridged the gap between ancient myth and scientific inquiry, proving that even thousands of years ago, humanity was capable of extraordinary intellectual achievements. As we marvel at the Babylonians' contributions, it's worth noting that they were just one of many ancient civilizations that looked to the stars for answers. Among them, the Egyptians stand out for their own unique approach to astronomy, blending it seamlessly with their culture, religion, and architecture. But that's a story for another moment. The Mayans were masters of the skies, their eyes fixed on the heavens in a quest to decode the movements of celestial bodies. At the heart of their astronomical knowledge lies the Dresden Codex, one of the few surviving Mayan manuscripts. This ancient text, filled with intricate glyphs and calculations, reveals a civilization deeply attuned to the rhythms of the cosmos. Among its most remarkable features is the detailed tracking of Venus, a planet the Mayans revered as both a god and a celestial clock. By meticulously charting its cycles lasting approximately 584 days, they could predict its appearances with astonishing precision, aligning their rituals and agricultural practices with its movements. Venus wasn't just a star in the sky, it was a divine force woven into the fabric of their daily lives. But the Mayans didn't stop at Venus. Their long count calendar, a system so precise it could measure time over thousands of years, stands as a testament to their advanced understanding of celestial mechanics. Unlike our modern calendar, which resets every year, the long count was designed to track vast epochs, allowing the Mayans to predict eclipses, solstices, and other astronomical events with remarkable accuracy. Imagine standing in one of their towering observatories. The stone structures aligned perfectly with the stars above, as priests and scholars worked tirelessly to record the heaven's secrets. These observatories weren't just buildings, they were gateways to the divine, places where the earthly and the celestial converged. The Mayans' connection to the stars went beyond science, it was deeply spiritual. Rituals were timed to coincide with celestial events, and the heavens were seen as a mirror of the god's will. When Venus rose as the morning star, it signaled a time of war. As the evening star, it marked a period of renewal and planting. This intricate dance between the cosmos and the earth shaped every aspect of Mayan life, from the planting of crops to the timing of battles. Their ability to integrate astronomy into their culture with such depth and sophistication is nothing short of breathtaking. As we marvel at the Mayans' celestial achievements, we can't help but wonder about the other ancient civilizations that also turned their gaze skyward. What secrets did they uncover, and how did their understanding of the stars shape their world? Stay with us as we journey to another corner of the ancient world, where the stars told stories just as profound. The ancient Egyptians weren't just master builders, they were master timekeepers, using the stars above as their guide. One of their most fascinating tools was the star clock, a celestial innovation that allowed them to track time with remarkable precision. By dividing the night into segments called decans, they mapped the sky into 36 star groups, each representing a 10-day period. These decans rose and set in a predictable pattern, acting as a cosmic calendar that helped them navigate both time and space. But their celestial obsession went far beyond timekeeping. The alignment of the Great Pyramid of Giza with the North Star, known as Thuban in ancient times, is a testament to their advanced astronomical knowledge. The pyramid's northern shaft points directly toward Thuban, which held a sacred place in their cosmology. This alignment wasn't just practical, it was deeply symbolic, connecting the pharaohs to the heavens and ensuring their journey to the afterlife. Experts believe the Egyptians' understanding of the stars was far more sophisticated than we once thought. They didn't just observe the skies, they integrated their knowledge into their architecture, religion, and daily life. The pyramids themselves are a testament to this, serving as both tombs and celestial observatories. As we marvel at the Egyptians' ingenuity, it's worth noting that their celestial achievements were just one piece of a much larger puzzle. Across the world, other ancient civilizations were also gazing at the stars, unlocking secrets of the universe in their own unique ways. Next, we'll journey to ancient India, where astronomers made groundbreaking discoveries that would shape our understanding of the cosmos for centuries to come. But while the skies above India inspired profound discoveries, the ancient Chinese were also gazing upward, weaving their own celestial tapestry. The Vedas and Surya Siddhanta reveal a civilization deeply connected to the cosmos, not just through observation but through mathematical precision. These texts, dating back thousands of years, contain astonishingly accurate calculations of planetary motions. Imagine this: long before telescopes or modern tools, Indian astronomers mapped the movements of the sun, moon, and planets with remarkable clarity. They even proposed a heliocentric model of the solar system, suggesting that the sun was at the center centuries before Copernicus would echo this idea in the West. What's equally fascinating is how they intertwined their celestial knowledge with daily life. Astronomy wasn't just a science, it was a spiritual practice. The Vedas describe rituals timed with celestial events, aligning earthly ceremonies with cosmic cycles. This harmony between science and spirituality is a hallmark of ancient Indian culture. And let's not forget their groundbreaking contributions to mathematics. The Surya Siddhanta, for example, laid the foundation for trigonometry, introducing sine functions that would later shape the field. This blend of precision and philosophy reveals a civilization that saw the stars not just as distant lights, but as guides both for navigation and for understanding the universe's deeper rhythms. And as we shift our gaze eastward, we'll see how the ancient Chinese took a different but equally awe-inspiring approach to the heavens. From star maps to the world's first recorded supernova, their astronomical achievements are nothing short of extraordinary. Now, let's turn our gaze to ancient China, where the heavens were not just a source of wonder but a vital tool for understanding the world. The Chinese tradition of astronomy is one of the most detailed and systematic in history, stretching back over 2 millennia. During the Han Dynasty, which began around 206 BC, Chinese astronomers began meticulously mapping the stars and recording celestial events with remarkable precision. These records weren't just for curiosity, they were deeply intertwined with imperial governance, helping rulers predict events, guide agricultural practices, and even interpret omens. One of the most astonishing achievements of Chinese astronomy was their discovery of supernova. Unlike many ancient cultures who might have seen a sudden bright star in the sky and interpreted it as a divine sign, Chinese astronomers documented these events with scientific rigor. For example, in 1054 CE, they recorded the appearance of what we now call the Crab Nebula supernova, a cosmic explosion so bright it was visible even during the day. These records are invaluable to modern astronomers, offering a rare glimpse into the behavior of stars over centuries. But perhaps the crown jewel of Chinese astronomical records is the Dunhuang Star Atlas. Discovered in a hidden library in the Mogao Caves, this ancient map is one of the oldest surviving star charts in the world, dating back to the Tang Dynasty around the 7th century CE. The atlas depicts over 1,300 stars, organized into constellations and accompanied by detailed notes. What makes it extraordinary is its accuracy. It's not just a symbolic representation but a practical tool for navigation and timekeeping. The Dunhuang Star Atlas stands as a testament to the sophistication of Chinese astronomy, blending artistry and science in a way that still inspires awe today. As we marvel at the precision and dedication of ancient Chinese astronomers, it's impossible not to wonder how their work influenced other civilizations. This brings us to the next chapter of our journey, the Islamic Golden Age, where astronomers built upon these traditions and pushed the boundaries of human understanding even further. From star maps to groundbreaking discoveries, the story of astronomy is a tapestry woven by cultures across the globe, each contributing a unique thread to the grand narrative of our cosmic exploration. The Islamic Golden Age, spanning from the 8th to the 13th century, was a period of extraordinary scientific advancement, and astronomy stood at the forefront of these achievements. Among the many tools and instruments developed during this era, the astrolabe emerged as one of the most remarkable. This intricate device, often described as a computer of the ancient world, was not just a scientific instrument but a versatile tool that shaped daily life. Its primary function was to measure the position of celestial bodies, but its uses extended far beyond stargazing. Sailors relied on it for navigation, determining their position by the stars. Religious communities used it to calculate prayer times and the direction of Mecca. Even farmers and travelers found it invaluable for telling time and predicting seasonal changes. At the heart of this innovation were brilliant minds like al-Battani, whose precise astronomical observations corrected earlier Greek and Roman calculations. His work laid the foundation for later discoveries, including the accurate measurement of the solar year. Another towering figure was al-Sufi, whose detailed star catalogue, the Book of Fixed Stars, mapped the night sky with unprecedented accuracy. These scholars didn't just build on earlier knowledge, they transformed it, blending empirical observation with mathematical rigor. Their contributions ensured that the astrolabe became more than a tool. It was a symbol of the Islamic world's dedication to understanding the cosmos. As we marvel at these achievements, it's worth noting how deeply interconnected these advancements were with the broader scientific traditions of the ancient world. The Islamic Golden Age didn't exist in isolation. It absorbed, refined, and expanded upon the knowledge of earlier civilizations. And speaking of earlier civilizations, our journey now takes us back even further in time, to the cradle of Western astronomy, ancient Greece. There, amidst the philosophers and thinkers, we'll uncover the origins of some of the most enduring astronomical theories that shaped our understanding of the universe. The ancient Greeks were masterful thinkers, and their contributions to astronomy laid the foundation for centuries of scientific exploration. At the heart of their understanding of the cosmos was the geocentric model, a groundbreaking idea that placed Earth at the center of the universe. This concept, though later proven incorrect, was a monumental step in humanity's quest to map the heavens. The Greeks didn't just stop at placing Earth at the center. They meticulously observed the movements of the planets, stars, and the sun, crafting a system that sought to explain the seemingly erratic paths of these celestial bodies. One of the most influential figures in this era was Claudius Ptolemy, whose work, The Almagest, became the cornerstone of astronomical thought for over 1,000 years. Ptolemy didn't just compile existing knowledge, he refined it, using geometry to create a complex system of epicycles and deferents. These mathematical tools allowed him to explain why planets sometimes appeared to move backward in the sky, a phenomenon known as retrograde motion. While his model was intricate and mathematically elegant, it was ultimately a product of its time, built on the belief that Earth was stationary. Yet, it's impossible to overstate the impact of Ptolemy's work. The Almagest wasn't just a scientific text, it was a bridge between the ancient world and the Renaissance. preserving and advancing knowledge that would fuel future discoveries. What's truly remarkable about the Greeks is how they blended philosophy, mathematics, and observation to make sense of the cosmos. They didn't have telescopes or modern instruments, but they used geometry to unlock the secrets of the skies. Their ability to predict celestial events with surprising accuracy speaks to their ingenuity and dedication. Of course, their geocentric model was eventually replaced by the heliocentric theory, but the Greeks' contributions remain a testament to the power of human curiosity and intellect. As we marvel at their achievements, it's worth noting that the Greeks didn't work in isolation. Their ideas were shaped by earlier civilizations, and their work, in turn, influenced countless others. This interconnectedness of knowledge is a recurring theme in the history of astronomy, and it sets the stage for our next exploration: the ancient observatories that served as the epicenters of celestial discovery. These structures, built by cultures across the globe, were more than just places to observe the stars. They were monuments to humanity's enduring fascination with the universe. Long before telescopes and modern technology, ancient civilizations looked to the skies with a sense of wonder and precision, constructing monuments that doubled as both observatories and calendars. Stonehenge, the iconic stone circle in England, is perhaps the most famous example. Its massive stones, arranged in a precise circle, align with the rising and setting sun during the solstices, marking the longest and shortest days of the year. But Stonehenge isn't just a calendar, it's a testament to the ingenuity of its builders, who likely used it to predict celestial events like eclipses, ensuring they could plan agricultural cycles and religious ceremonies with astonishing accuracy. Yet Stonehenge is far from the only ancient observatory. Across the Atlantic, the Maya constructed the Caracol in Chichen Itza, a spiral-shaped tower with narrow windows perfectly aligned to track the movements of Venus. For the Maya, Venus wasn't just a bright star, it was a celestial deity, and its cycles influenced everything from warfare to planting seasons. The Caracol's design reveals a deep understanding of astronomy, with its windows framing the planet's positions at key moments in its orbit. These structures weren't just tools for observation, they were also symbols of power and connection to the divine. The precision required to build them suggests that ancient astronomers possessed knowledge far beyond what we might expect. How did they achieve such accuracy without modern instruments? Theories range from generations of careful observation to mathematical calculations encoded into the very stones themselves. As we marvel at these ancient wonders, it's worth noting that their legacy extends beyond their original purpose. They remind us that humanity's quest to understand the cosmos is as old as civilization itself. And speaking of legacy, the next chapter of this story takes us into the realm of architecture itself, where the stars weren't just observed, they were immortalized in stone, carved into the very fabric of ancient cities. Stay tuned as we explore how celestial symbolism shaped the temples, pyramids, and monuments of the ancient world. One of the most fascinating ways ancient cultures demonstrated their astronomical prowess was through the deliberate alignment of their architecture with celestial bodies. These structures weren't just feats of engineering, they were carefully designed to reflect the heavens above, embedding cosmic knowledge into the very fabric of their societies. Take, for instance, the Great Pyramid of Giza. This iconic monument is often celebrated for its precision and scale, but what many don't realize is its profound connection to the stars. The three pyramids of Giza are arranged in a pattern that mirrors the three stars of Orion's belt. This isn't a coincidence, it's a deliberate act of celestial symbolism, reflecting the ancient Egyptians' belief in the afterlife and their connection to the gods who resided in the stars. The alignment wasn't just about marking the skies, it was a way to bridge the earthly and the divine, creating a physical representation of their spiritual beliefs. Across the globe, in the Andes Mountains of Peru, the Temple of the Sun at Machu Picchu tells a similar story. This sacred structure was designed with such precision that during the winter solstice, sunlight streams through a strategically placed window, illuminating a ceremonial stone at its center. This phenomenon wasn't just a marvel of architecture, it was a testament to the Incas' deep understanding of the sun's movements and their reverence for its life-giving power. The temple's alignment with the solstice served as both a calendar and a spiritual marker, reinforcing the connection between the heavens and the rhythms of life on Earth. These ancient builders didn't just observe the stars and the sun, they wove their movements into the very stones of their cities, creating monuments that were as much about science as they were about spirituality. But why did these ancient cultures go to such great lengths to align their architecture with the cosmos? For them, the heavens weren't just a distant spectacle, they were a source of guidance, wisdom, and divine power. By mirroring the stars and the sun in their structures, they sought to harmonize their lives with the greater order of the universe. These alignments weren't just symbolic, they were a way to encode their knowledge, ensuring that future generations could look to the skies and remember the lessons of their ancestors. And as we'll soon see, their mastery of the heavens went even further, as they began to predict and interpret celestial events like eclipses with astonishing accuracy. But that's a story for the next part of our journey. Imagine living in a world without telescopes or advanced mathematics, yet somehow being able to predict celestial events with jaw-dropping precision. That's exactly what ancient civilizations like the Babylonians and Chinese achieved when it came to predicting eclipses. These cultures didn't just see eclipses as random events. They saw patterns, rhythms, and cycles in the cosmos that allowed them to forecast these awe-inspiring moments with astonishing accuracy. The Babylonians, for example, were masters of the skies. They developed a method called the Saros cycle, a repeating pattern of eclipses that occurs every 18 years, 11 days, and 8 hours. By meticulously recording lunar and solar movements over centuries, they noticed that eclipses followed this predictable rhythm. This wasn't just a scientific breakthrough, it was a testament to their deep connection with the heavens. They believed eclipses were messages from the gods, and their ability to predict them gave them immense power and influence in their society. Meanwhile, in ancient China, eclipse prediction was equally sophisticated. Chinese astronomers carefully tracked the movements of the sun and moon, creating detailed records that spanned generations. They noticed that eclipses often occurred in clusters, separated by specific intervals. This knowledge wasn't just about science, it was deeply intertwined with their culture. Eclipses were seen as omens, often signaling the displeasure of the heavens or the need for the emperor to make amends. The ability to predict these events wasn't just about understanding the cosmos, it was about maintaining harmony between the heavens and the earth. What's truly remarkable is how these ancient methods, born out of careful observation and cultural significance, still hold up today. Modern astronomers still use the Saros cycle as a tool for eclipse prediction, proving that the wisdom of these ancient sky watchers was far ahead of its time. But beyond the science, eclipses held a deeper meaning for these civilizations. They were moments of awe, reverence, and even fear events that reminded people of their place in the vast, mysterious universe. And speaking of mystery, these celestial events weren't just about prediction, they were also the inspiration for countless myths and stories. From dragons swallowing the sun to cosmic battles between gods, eclipses sparked the imagination of ancient cultures, giving rise to tales that have endured for millennia. Which brings us to our next topic, the fascinating world of ancient star myth stories that wove the stars into the very fabric of human history. Have you ever looked up at the night sky and wondered why certain stars seem to form pictures that tell stories? For ancient cultures, constellations weren't just random patterns, they were celestial storybooks filled with myths, morals, and meanings. These star myths served as more than entertainment. They were tools for understanding the cosmos and preserving wisdom across generations. Let's take a closer look at how these stories shaped the way ancient people saw the heavens. Take the Greek myth of Orion, for example. This famous constellation, with its distinctive belt of 3 bright stars, was said to depict a mighty hunter. According to legend, Orion boasted he could hunt any creature on Earth, which angered the goddess Artemis. She sent a scorpion to defeat him, and after his death, the gods placed both Orion and the scorpion in the sky, but on opposite sides, so they'd never meet again. This tale not only explained the appearance of the stars, but also offered a lesson in humility and the dangers of hubris. It's a reminder that even the stars above carry echoes of human struggles and triumphs. On the other side of the world, the Chinese legend of the cowherd and weaver girl tells a different kind of story. This myth revolves around 2 stars, Altair and Vega, separated by the Milky Way. The cowherd, represented by Altair, and the weaver girl, symbolized by Vega, were lovers forbidden to be together. Once a year, on the 7th day of the 7th lunar month, magpies would form a bridge across the Milky Way, allowing them to reunite for a single night. This story not only explained the movement of these stars, but also became the basis for the Kixi festival, a celebration of love and devotion that continues to this day. These myths weren't just beautiful tales, they were practical tools for ancient societies. By linking celestial patterns to stories, people could remember the positions of stars, track the passing of seasons, and even navigate the seas. The night sky became a map, a calendar, and a classroom all at once, helping civilizations pass down knowledge long before the invention of writing. It's a testament to how deeply intertwined storytelling and science were in the ancient world. And speaking of calendars, these celestial stories laid the groundwork for some of the most sophisticated timekeeping systems ever created. But how did ancient cultures turn these myths into precise tools for marking time? That's a story for the next section, where we'll explore the fascinating world of ancient calendars and their enduring legacy. Now, let's turn our attention to one of the most fascinating intersections of ancient astronomy and daily life, timekeeping. Imagine living in a world without clocks or smartphones, where the rising and setting of the sun, the phases of the moon, and the positions of the stars were your only guides to understanding time. For ancient civilizations, creating accurate calendars wasn't just a scientific endeavor, it was essential for survival. Agriculture, religious rituals, and even governance depended on precise timekeeping, and the stars above provided the perfect roadmap. Take the Mayan long count calendar, for instance. This intricate system, which tracked time over vast periods, wasn't just a way to mark days or years, it was a cosmic clock. The Mayans believed that time moved in cycles, and their calendar was designed to predict these cycles with remarkable precision. By observing the movements of celestial bodies, they developed a calendar that could span thousands of years, allowing them to plan agricultural activities and align their religious ceremonies with celestial events. The long count wasn't just a tool, it was a reflection of their deep connection to the cosmos. Meanwhile, in ancient Egypt, the solar calendar reigned supreme. Unlike the Mayans, who focused on long cycles, the Egyptians prioritized the annual flooding of the Nile, which was critical for their agriculture. Their calendar, based on the sun's movement, divided the year into 12 months of 30 days each, with 5 extra days added to align with the solar cycle. This system was so accurate that it became the foundation for the calendar we use today. The Egyptians didn't just track time, they synchronized their entire society with the rhythms of the heavens. What's truly remarkable about these ancient calendars is how they reveal the interplay between astronomy and human ingenuity. Both the Mayans and the Egyptians didn't just observe the stars, they used them to create systems that shaped their cultures. These calendars were more than tools, they were expressions of humanity's desire to understand and harness the cosmos. And as we move forward, we'll see how this same celestial knowledge guided ancient explorers across vast oceans, using the stars not just to mark time, but to navigate the world itself. Imagine setting sail across vast, uncharted oceans with nothing but the stars above to guide your way. For ancient sailors, the night sky wasn't just a source of wonder, it was a map, a compass, and a lifeline. Long before the invention of GPS or even the magnetic compass, civilizations like the Polynesians and Vikings mastered the art of celestial navigation, using the stars to traverse thousands of miles of open water with astonishing precision. The Polynesians, for example, were some of the most skilled navigators in history. They didn't rely on written maps or instruments, but instead memorized the positions of stars, the patterns of ocean swells, and even the behavior of birds to chart their courses. They called this method wayfinding, and it allowed them to settle islands scattered across the Pacific Ocean from Hawaii to New Zealand. Key to their success were the star paths, specific sequences of stars that rose and set at predictable points on the horizon. By aligning their voyages with these celestial markers, they could navigate with remarkable accuracy, even over vast distances. Meanwhile, far to the north, the Vikings were also harnessing the power of the heavens. In the often cloudy skies of the North Atlantic, they relied on a mysterious tool known as the sunstone. This crystal, possibly made of calcite or cordierite, had a unique property. It could filter sunlight, revealing the sun's position even on overcast days. By rotating the stone until the light passing through it aligned, Viking navigators could determine the sun's direction, helping them maintain their course even when the sky was obscured. And then there was the North Star, or Polaris, a constant beacon in the northern sky. Unlike other stars that moved throughout the night, Polaris remained almost stationary, making it an invaluable reference point for travelers. Ancient mariners in the Mediterranean, for instance, used it to guide their ships along trade routes, while explorers in the Arctic relied on it to navigate the icy waters of the far north. Constellations like Ursa Major and Cassiopeia also played crucial roles, helping sailors orient themselves and confirm their positions. These ancient navigators didn't just look to the stars, they understood them intimately, turning the night sky into a living, breathing guidebook. Their achievements remind us that the heavens have always been more than just a backdrop to human history. They've been an active participant in our journey across the globe. And speaking of journeys, the stars weren't the only tools ancient civilizations used to explore the cosmos. Next, we'll uncover the fascinating world of ancient astronomical instruments, tools that allowed people to measure time, predict celestial events, and unlock the secrets of the universe itself. One of the most fascinating aspects of ancient astronomy is the ingenuity behind the tools they created to study the heavens. These instruments, crafted with precision and purpose, allowed ancient astronomers to make remarkable discoveries without the technology we take for granted today. Among the most notable are the gnomon, the merkit, and the armillary sphere, each a testament to humanity's early quest to understand the cosmos. Take the gnomon, for example. This simple yet effective tool was essentially a vertical stick or rod planted in the ground. By observing the shadow it cast as the sun moved across the sky, ancient astronomers could measure time, track the seasons, and even determine the Earth's axial tilt. It's incredible to think that such a straightforward device laid the groundwork for more advanced timekeeping systems and our modern understanding of the Earth's relationship with the sun. Then there's the merkit, an instrument used by the ancient Egyptians. This tool, often described as a sighting stick, allowed astronomers to align their observations with the stars. By using plumb lines and a forked sight, they could chart the movement of celestial bodies with astonishing accuracy. The merkit wasn't just a tool for stargazing, It was a critical piece of technology for aligning temples and monuments with astronomical events, showcasing how intertwined astronomy was with their culture and architecture. Perhaps one of the most sophisticated instruments of the ancient world was the armillary sphere. Originating in ancient Greece and later refined by Chinese astronomers, this device consisted of a series of interconnected rings representing celestial circles like the equator and the ecliptic. It allowed astronomers to model the apparent motion of stars and planets, providing a three-dimensional understanding of the heavens. The armillary sphere wasn't just a tool for observation. It was a visual representation of the cosmos, helping thinkers of the time grapple with the complexities of celestial mechanics. These instruments didn't just serve their immediate purposes, they laid the foundation for future scientific advancements. The principles behind the gnomon influenced the development of sundials, while the armillary sphere inspired later models of the universe, including those used during the Renaissance. Even the Merc-its precision in alignment found echoes in the construction of telescopes centuries later. These tools remind us that the pursuit of knowledge is a continuous journey, with each generation building on the discoveries of the past. As we marvel at these ancient instruments, it's impossible not to wonder, how did the thinkers of the past interpret the data they gathered? What theories did they develop about the nature of the cosmos? That's where our journey takes us next, into the realm of ancient cosmological theories, where imagination and observation collided to shape humanity's earliest understanding of the universe. Among the many wonders of ancient astronomy, perhaps none is more fascinating than the way early civilizations imagined the cosmos itself. For the ancient Egyptians, the sky wasn't just a vast expanse of stars, it was the goddess Nut, her body arched protectively over the earth, her fingertips and toes touching the horizon. Each night she swallowed the sun, and each morning she gave birth to it anew. This poetic vision wasn't just mythology, it was a way of explaining the rhythms of day and night, the cycles of life and death, and humanity's place within the grand tapestry of the universe. Meanwhile, across the Mediterranean, the Greeks were crafting their own cosmic theories. Thinkers like Pythagoras and later Aristotle envisioned the heavens as a series of concentric spheres, each carrying a celestial body in its perfect, eternal orbit. The outermost sphere held the fixed stars, while the inner ones guided the sun, moon, and planets. This model wasn't just a scientific framework, it reflected a belief in harmony and order, a universe governed by mathematical precision. And yet, even as these ideas evolved, they remained deeply intertwined with the spiritual and philosophical questions of the time. What's striking about these ancient cosmologies is how they reveal the human desire to find meaning in the stars. Whether it was the Egyptians seeing divine figures in the constellations or the Greeks mapping the heavens with geometry, these cultures weren't just observing the sky, they were interpreting it. Their cosmologies became a bridge between the seen and the unseen, the known and the mysterious, shaping not only their understanding of the universe but also their art, religion, and daily lives. And as we turn from these ancient visions of the cosmos, we'll see how their legacy continues to echo through the ages. From the star charts of medieval scholars to the telescopes of modern astronomers, the ideas born in these early civilizations laid the foundation for our ongoing quest to understand the universe. But that's a story for the next chapter. But how did the ideas of ancient astronomers, born in a time without telescopes or calculators, manage to shape the future of science so profoundly? The answer lies in their relentless pursuit of understanding the cosmos, a quest that left an indelible mark on the minds of future giants like Copernicus and Kepler. Copernicus, often hailed as the father of modern astronomy, didn't just wake up one day and decide the Earth revolved around the sun. His groundbreaking heliocentric theory was deeply influenced by the works of ancient astronomers like Aristarchus of Samos, who had proposed a similar idea over 1,000 years earlier. Though Aristarchus's model was dismissed in his time, Copernicus saw the genius in it, refining it with the mathematical precision that would later redefine our understanding of the universe. Then there's Johannes Kepler, whose laws of planetary motion are still taught in classrooms today. Kepler was inspired by the meticulous observations of ancient Babylonian and Greek astronomers who had mapped the night sky with astonishing accuracy. Their data, preserved through centuries, allowed Kepler to uncover the elliptical orbits of planets, a discovery that would become a cornerstone of Newton's laws of motion. The legacy of these ancient thinkers isn't just a footnote in history. It's the very foundation upon which modern science stands. Their methods of observation, their willingness to question the status quo, and their dedication to recording celestial patterns laid the groundwork for the scientific revolution. Even today, their discoveries continue to inspire, reminding us that the pursuit of knowledge is a timeless endeavor. As we marvel at how far we've come, it's worth remembering that many of the greatest achievements in astronomy are still hidden in the shadows of history. In our next section, we'll uncover some of these lesser-known triumph stories that might not be as famous as Copernicus or Kepler, but are no less extraordinary. High in the Andes, the Inca civilization achieved something truly remarkable, a feat of astronomy so precise it still inspires awe today. Hidden among their greatest accomplishments are the sun pillars, or Intihuatana, stone structures designed to track the movements of the sun with astonishing accuracy. These pillars weren't just tools for observation. They were deeply woven into the fabric of Inca life, marking the solstices and equinoxes with a level of precision that rivals modern instruments. The Inca used these pillars to determine the changing seasons, which was crucial for their agricultural practices. By observing the shadows cast by the sun at specific times of the year, they could predict when to plant and harvest crops, ensuring the survival of their empire. But these pillars weren't just practical, they held profound spiritual significance. For the Inca, the sun was a deity, and tracking its movements was a way of honoring their gods and maintaining harmony with the cosmos. What's often overlooked is the sheer ingenuity behind these structures. Without advanced tools or written records, the Inca achieved a level of precision that modern astronomers still admire. The pillars were carefully calibrated to align with the sun's path, a testament to their deep understanding of celestial patterns. Yet, despite their brilliance, these achievements are rarely mentioned in the same breath as other ancient wonders. The sun pillars remind us that some of history's greatest innovations are hidden in plain sight, waiting to be rediscovered. And speaking of rediscovery, the next chapter of our journey takes us into the world of ancient astronomical texts, records that offer a glimpse into how civilizations across the globe mapped the stars and charted their place in the universe. One of the most remarkable ways ancient civilizations preserved their astronomical knowledge was through meticulously written texts, many of which have survived the test of time. Among these, two stand out as true pillars of ancient science: the Almagest by Claudius Ptolemy and the Surya Siddhanta from ancient India. These works weren't just records of observations, they were comprehensive guides that shaped how future generations understood the cosmos. Ptolemy's Almagest, written in the 2nd century, became the definitive text on astronomy in the Western world for over 1,000 years. It laid out detailed models of planetary motion, star catalogs, and methods for predicting celestial events with astonishing accuracy. Meanwhile, the Surya Siddhanta, believed to date back to at least the 4th or 5th century, offered a sophisticated system of calculations for tracking the movements of the sun, moon, and planets. It even included advanced concepts like trigonometry, which were far ahead of their time. What's truly fascinating is how these texts didn't just sit on shelves gathering dust, they were actively studied, copied, and translated across cultures. The Almagest traveled from ancient Greece to the Islamic world, where scholars refined its models and passed them on to medieval Europe. Similarly, the Surya Siddhanta influenced astronomers across South and Southeast Asia, leaving a lasting legacy in regions like Cambodia and Indonesia. These texts weren't just repositories of knowledge, they were bridges connecting civilizations, ensuring that the wisdom of the stars was never lost. But the impact of these texts goes even deeper. They didn't just preserve knowledge, they inspired innovation. The mathematical frameworks and observational techniques within them laid the groundwork for later breakthroughs in astronomy. Think about it, without the Almagest, would Copernicus have dared to challenge the geocentric model? Without the Surya Siddhanta, would Indian astronomers have developed such precise calendars and instruments? These texts were more than books, they were catalysts for progress, sparking curiosity and discovery across centuries. Of course, the story of ancient astronomy isn't just told through words, it's also etched in art. From intricate celestial maps to stunning depictions of the heavens, ancient cultures found countless ways to bring the cosmos to life. And that's where we're headed next, exploring how ancient astronomical art captured the wonder of the skies and preserved it for future generations. One of the most fascinating ways ancient cultures expressed their understanding of the cosmos was through art. From intricate carvings to vivid paintings, celestial phenomena weren't just observed, they were immortalized in stunning works of creativity. Take, for instance, the Nebra sky disk, a bronze artifact dating back to around 1600 BCE. This remarkable piece, discovered in Germany, is one of the oldest known representations of the night sky. It features a cluster of stars, a crescent moon, and what many believe to be the sun or a full moon. But this isn't just a simple map, it's a symbolic masterpiece. Researchers suggest the disk may have been used as a tool for tracking lunar and solar cycles, blending practical astronomy with spiritual significance. It's a testament to how ancient people saw the heavens as both a guide and a source of divine inspiration. Equally captivating are the tomb paintings of ancient Egypt. These vibrant artworks often depict gods and goddesses associated with celestial bodies, like Nut, the sky goddess, whose arched body was believed to cradle the stars. In many tombs, you'll find detailed star maps and depictions of solar boats, symbolizing the sun's journey across the sky and its nightly passage through the underworld. These images weren't just decorative, they were deeply symbolic, reflecting the Egyptians' belief in the interconnectedness of the cosmos, the afterlife, and the divine. Every brushstroke carried meaning, turning walls into windows to the heavens. What's truly remarkable is how these artistic depictions weren't just about beauty or storytelling. They were a way for ancient cultures to encode their knowledge of the skies, preserving it for future generations. The stars, planets, and celestial events weren't just distant objects, they were woven into the fabric of their myths, rituals, and daily lives. And as we uncover more of these ancient artworks, we gain a deeper appreciation for how they saw the universe not just as something to study, but as something to honor and celebrate. This profound connection between the skies and sacred practices brings us to our next exploration: the rituals and ceremonies ancient civilizations performed to honor the heavens. How did they use their understanding of the stars to create traditions that shaped their societies? Let's dive deeper into the world of ancient astronomical rituals. Now let's step into the world of ancient rituals where the stars weren't just distant lights in the sky, they were central to the very fabric of life. For civilizations like the Maya and the Egyptians, astronomy wasn't just a science, it was a spiritual guide deeply woven into their ceremonies and traditions. Take the Mayan ball game, for example. This wasn't just a sport, it was a cosmic reenactment. The ball court itself symbolized the heavens, with the ball representing celestial bodies like the sun or the moon. Players weren't merely competing for victory, they were acting out a sacred drama, their movements echoing the eternal dance of the stars. The outcome of the game was believed to influence the balance of the cosmos itself, shaping everything from the seasons to the harvest. Similarly, in ancient Egypt, temples weren't just places of worship, they were meticulously designed to align with the stars. The priests who conducted ceremonies within these sacred spaces were also skilled astronomers, tracking the movements of celestial bodies to determine the most auspicious times for rituals. The rising of Sirius, for instance, marked the annual flooding of the Nile, a life-giving event that was celebrated with grand ceremonies. These rituals weren't just about honoring the gods, they were about maintaining harmony between the earthly and the celestial realms. The Egyptians saw the cosmos as a reflection of their own world, and their ceremonies were a way of ensuring that this delicate balance was preserved. What's fascinating is how these rituals reveal the depth of ancient astronomical knowledge. The Mayans, for example, used their understanding of the stars to create a calendar system that accurately predicted celestial events for centuries. Their ceremonies weren't just symbolic, they were rooted in precise observations of the night sky. The Egyptians, too, used their astronomical expertise to align their pyramids and temples with incredible precision, ensuring that these structures were in harmony with the movements of the heavens. These practices show us that for ancient civilizations, astronomy wasn't just about studying the stars, it was about connecting with them on a profound, almost spiritual level. As we explore these ancient rituals, it's impossible not to marvel at how deeply the cosmos influenced every aspect of life for these cultures. But what happens when we shift our focus from the ceremonial to the predictive? How did ancient astronomers use their knowledge of the stars to foresee events that shaped their world? That's exactly what we'll uncover next as we delve into the realm of ancient astronomical predictions. But how did ancient astronomers, without the tools we have today, manage to predict the movements of planets like Venus and Mars with such precision? This wasn't just guesswork. It was the result of meticulous observation and groundbreaking methods that laid the foundation for modern astronomy. Take the Babylonians, for instance. Over 2,000 years ago, they recorded the positions of planets with astonishing detail, creating some of the earliest known astronomical diaries. These records weren't just notes, they were part of a sophisticated system that allowed them to predict planetary movements decades in advance. One of their most remarkable achievements was their understanding of the cycles of Venus. They noticed that Venus appeared in the sky at regular intervals, and by tracking these patterns, they could forecast its movements with incredible accuracy. Similarly, the Mayans, thousands of miles away, developed their own complex calendar systems that tracked the movements of Mars and other celestial bodies. Their predictions were so precise that they could anticipate events like eclipses and planetary alignments, which they often tied to their religious and agricultural practices. What's even more fascinating is how these ancient methods compare to modern astronomy. While we now rely on telescopes and advanced mathematics, the core principles, like observing patterns and cycles, remain the same. The work of these early astronomers wasn't just about predicting the future, it was about understanding the universe. Their contributions didn't just satisfy curiosity, they paved the way for the scientific advancements we benefit from today. This dedication to studying the skies wasn't limited to a single culture or region. From the Greeks, who introduced geometric models to explain planetary motion, to the Chinese, who meticulously documented celestial events, the collective efforts of ancient astronomers created a global foundation for astronomical knowledge. Their methods may have been different, but their goal was the same: to decode the mysteries of the cosmos, and as their understanding grew, so did their ability to teach and pass on this knowledge. This brings us to the next chapter in their story: how ancient civilizations not only observed the stars, but also built systems to educate future generations about the wonders of the universe. But how did ancient civilizations ensure that the secrets of the stars were not lost to time? The answer lies in their sophisticated systems of education, where astronomical knowledge was carefully preserved and passed down through generations. Temples often served as the epicenters of learning, where priests and scholars studied the heavens with meticulous care. These sacred spaces weren't just places of worship, they were also the universities of their time, where the brightest minds gathered to decode the mysteries of the cosmos. In Mesopotamia, for example, scribes meticulously recorded celestial observations on clay tablets, creating a library of knowledge that would endure for millennia. Similarly, the House of Wisdom in Baghdad became a beacon of intellectual progress during the Islamic Golden Age, where scholars from across the world translated and expanded upon ancient texts, ensuring that astronomical wisdom thrived even as empires rose and fell. But it wasn't just written records that kept this knowledge alive. Oral traditions played a crucial role, especially in cultures where writing was less developed. Stories, songs, and rituals became vessels for passing down celestial insights, embedding astronomical knowledge into the very fabric of daily life. Schools, too, were instrumental. In ancient Greece, the academy founded by Plato became a hub for studying the stars, blending philosophy with astronomy. In India, Gurukul's traditional schools taught students not just the movements of planets but also the spiritual significance of celestial events. This blend of education and spirituality ensured that astronomical knowledge wasn't just about science, it was about understanding humanity's place in the universe. And speaking of understanding, it's fascinating how these ancient teachings often intertwined with mythology. The stars weren't just points of light, they were gods, heroes, and symbols of divine will. This connection between astronomy and mythology is where our journey takes us next, as we explore how ancient cultures wove the cosmos into their stories, beliefs, and legends. Have you ever wondered why ancient civilizations looked to the stars and saw not just lights in the sky, but stories? The relationship between astronomy and mythology in ancient cultures wasn't just a casual connection, it was a profound, symbiotic bond. For our ancestors, the heavens were more than a scientific curiosity. They were a canvas for storytelling, a way to explain the unexplainable, and a bridge between the earthly and the divine. Take the Greeks, for example. When they gazed at the night sky, they didn't just see constellations, they saw heroes, gods, and epic tales. Orion, the hunter, wasn't just a pattern of stars, he was a figure from legend, forever immortalized in the heavens. The Pleiades weren't merely a cluster of stars, they were seven sisters transformed by the gods to escape Orion's pursuit. These myths weren't just stories, they were explanations. Why did the stars move the way they did? Why did the seasons change? The answers for the ancients lay in the myths that gave meaning to the cosmos. But this relationship went both ways. Astronomy didn't just inspire myths, it shaped entire belief systems. In ancient Egypt, the annual flooding of the Nile was tied to the rising of Sirius, the brightest star in the sky. This celestial event wasn't just a marker of time, it was a divine signal, a gift from the gods that ensured the land's fertility. The Mayans, too, built their calendar around the movements of Venus, believing it to be a harbinger of war and prosperity. For them, astronomy wasn't separate from religion, it was its beating heart. This intertwining of science and storytelling had a lasting impact. Even today, we see traces of these ancient beliefs in our own culture. The names of planets, constellations, and even days of the week are rooted in mythological traditions. Mars, the red planet, bears the name of the Roman god of war. Wednesday, that's Woden's Day, named after the Norse god Odin. These are more than just linguistic relics, they're reminders of how deeply astronomy and mythology shaped human history. As we near the end of our journey through ancient astronomy's greatest achievements, it's worth reflecting on how these early stargazers didn't just observe the sky, they lived it. Their myths, their gods, their very understanding of the world were written in the stars, and in a way, that's a legacy that still shines brightly today. As we wrap up this journey through the remarkable achievements of ancient astronomy, it's impossible not to marvel at the sheer ingenuity of our ancestors. From the precise alignment of Stonehenge to the intricate star maps of the Babylonians, these early astronomers didn't just observe the heavens, they decoded them, laying the foundation for everything we know about the cosmos today. Their work wasn't just about tracking celestial movements, it was about understanding humanity's place in the universe, a question that still drives us forward. What's truly astonishing is how these ancient discoveries resonate even now. The Mayan calendar, for instance, wasn't just a tool for marking time. It was a sophisticated system that connected celestial cycles to human life. And let's not forget the Antikythera Mechanism, a device so advanced it wouldn't be matched for over 1,000 years. These weren't just feats of engineering or math, they were expressions of a profound curiosity, a desire to unlock the mysteries of the cosmos that we still share today. This legacy of ancient astronomy isn't just a historical footnote, it's a living, breathing part of modern science. The methods and insights of these early stargazers paved the way for everything from the Copernican revolution to the Hubble Space Telescope. Their work reminds us that the pursuit of knowledge is timeless, a thread that connects us across centuries and cultures. To close, let's reflect on the words of Carl Sagan, who once said, "Somewhere, something incredible is waiting to be known." This sentiment captures the essence of what drove ancient astronomers and what continues to inspire us today. Their achievements are a testament to the power of curiosity and the enduring human spirit of exploration. So, what do you think? How do these ancient discoveries shape your view of the universe? Share your thoughts in the comments below, and don't forget to like and subscribe for more journeys into the mysteries of our past. The cosmos is vast, and there's always more to discover.